Hello guys, today I will be explaining you a project that is LazyTune, and the project is about hyperparameter tuning. So if you know machine learning, then I think you know about GridSearchCV and other hyperparameter tuning tools like GridSearchCV and randomized search CV, and also there is another tool like hyperplot of tuna. This is a very famous tool for hyperparameter tuning. So this is like okay, so the grid search CV and randomized search CV, hyperplot, optuna. These are the tools for hyperparameter tuning. Okay, so the basic thing, that is, the maximum people use GridSearchCV because this will give the result that is obviously unique, and also this will give you the correct answer. And this is, you can see the learning curve is low, so you can easily learn this and use this. But the main problem in GridSearchCV is this is very slow. This is very slow because if you know about the GridSearchCV, how the GridSearchCV works, then you will find why this is very slow. Suppose your grid is looking like that. Grid is equal to parameter 1, you are giving 2 options in parameter 1, and in parameter 2 you are giving 3 options, 1 2 3. Okay, and if you draw the parameter grid, then this is like the total combination is here 2 and here 3, the total combination 6. Okay, so total 6 combinations, 1 2 3, and here 1 and 2. This is for parameter 1, this is for parameter 2. What GridSearchCV does, GridSearchCV just evaluate all the models with the whole data. Means they will train all the models, the total 6 models, with the whole data, the whole data that is given for testing. Okay, so this is very computationally expensive, and this takes a lot of time. So what I have done, we have done a project. The name of the project is LazyTune. What LazyTune does, LazyTune simply follows a rule, that is, at the first stage this is doing screening, screening, this is screening phase. The second stage, this is pruning, and third stage, that is full training. Okay, how this is working, in the screening phase, suppose you are given a data set, that is this is x, this is y, x1 x2 and y. This is output column. Okay, so at first you are doing TTS, train test split. This is train data and this is test data, and in the training data you are doing another split, this that is small train split, and this is validation split. Okay, the small train split is, you can the thing is like, in the TTS you are taking suppose 80%, and here 20% of the whole data. This is 100%, and you are taking 80%, 20% of the whole data. Train test split, this is train, this is test, this is yx, xy. Okay, so in the training data you are doing the split, like small train split and validation split. This is how the validation split is more. Suppose this is 80% or not 80%, 70%, and this is 30%. Okay, so yes, this is 30%, this is 70%, and with this data you are doing the screening phase, like you are training the all. Suppose here I have took the 6 models, but I am taking here 100 models, 100 combinations or 100 models. So you have 100 models and you are doing the training with this small data set, this 30% of the 80% training data set. Okay, you are doing the small you are doing the training with the small data set to that 100 models. You are training the 100 models, okay, with this small 30% data set. So what you will do, the model is trained, and for testing you are using this data set, this validation split data set. Okay, you are testing the models and you will get a metric score. Suppose for model 1 you will get something, for model 2 you will get something, model 3 you will get something, model 100 you will get something, and after that you are sorting these according to the matrices. Okay, so if you sort, suppose model 3 is the highest, and model 5, then model 1, then model 89, then model anything, model 1 or model 2 at the last. Okay, this is sorted matrices. So you can get that some models are really good, these models are really good, and the other models are really bad on this data, on this small data. And I am assuming that these upper models, these good models are really good for the future also, for the whole data also. So I am pruning, like this is whole the screening phase, these are the whole screening phase. Okay, and the pruning phase is like here I am pruning the data, I am pruning the models. Suppose I have pruned 90% models pruned, means only I am taking the best 10 models, 90% of 100 models pruned, means 10 models remained. So I am taking the 10 models that are best. Okay, after sorting I am taking the first 10 models. So these 10 models, we have got these 10 models, and we know that these 10 models are great, and these 10 models are good for the training. Okay, for better parameters, for better parameters, actually is the better answers or better matrices. So we took this whole data and train with this 10 models. We will train that model, best 10 models, with the whole data, whole given data. Okay, this is the main idea, whole given data. And after that you will get another list of matrices. Suppose here are 10 models, so m1, m2, m3, m4, m5, m6, m10, and from that you are doing sorting you have sorted the models, and you have got a sorted list like M5, M1, M3, M4, and at last suppose M2. So from here you can take the best model, that is this is M9 or whatever, so M9 is the best, that is in the top, so M9 is the best. So you can get the answer and you will return the M9's params, like what the parameter is, this is the answer. So here what you can see, like the full data set, and you will dividing the data set into train and test, and after that you are dividing the train data into two sub data sets, that is small train split and one is validation split, and that small train split you will use for the screening phase, this first phase. And after that you can get a list, you will sort the list and you will pruning the bad models, and you are keeping the best models, the best few number of models. Suppose you have make the 10 models, okay, the 10 models are best, the first 10 models you have choose, and after that you are doing training with the whole data set to the 10 models, that base 10 models, and after that you will get a list of parameters or list of matrices. You will sort that, after sorting you can get the best of the list, okay, and suppose here is the best is M9, so you are returning the answer of the M9. This is the whole project, and I can also show you the repo and all. This is the LazyTune repository, and here I have explained all the things and all the things how you can use that. And also this is the website, this is a demo website, this is only the front end, this is a demo website and documentation how to use that. Yes, here you can upload dataset and you can try in the browser, and I am doing the test in the Kaggle. Suppose so at first what I can do, import scikit-learn, import scikit-learn dot model selection, import train test split, scikit-learn dot ensemble, random forest classifier. We will be using the random forest classifier for the model, for the main model which we will train, okay. From scikit-learn dot matrices import accuracy score. Our matrices will be accuracy score. Yes. So these are all invalid syntax. Okay, sorry, from, yes, and we have one thing, import from LazyTune import smart search. This is that is my model. Okay, we have to install the LazyTune code. Click install LazyTune. pd is equal to df is equal to pd dot read csv. Yes, df, and it got that data. This that is a diabetes data. Obviously this is not a large data, this is a small data. So x is equal to df dot drop target axis is equal to 1, y is equal to df of target. Okay, and then split x train, y train, x test. Y train, y test is equal to, we have to use train test split x comma y comma and then statement test size. Okay, model dot model plus params. Model is equal to, we will use random forest classifier. Random state is equal to 42. Parameter grid with which will be the parameter grid, that is in estimators is equal to 50, 100 suppose, and max depth is equal to suppose none, 5, 10 and none. Max depth. Mean sample split is equal to suppose 2 and 5. After that, max sample split 2, 5, 10 in estimators, and max depth, mean sample split is a spelling mistake, and max sample split. Okay, this is done. And now use the GridSearchCV, because we are making the experiment for the comparison of GridSearchCV and LazyTune. So GridSearchCV, suppose this is grid is equal to, okay, we have to import the GridSearchCV. GridSearchCV, grid ACRCH. Okay, yes, GridSearchCV imported. GridSearchCV done. Okay, estimator is equal to model, obviously, and then param grid parameter grid. CV is equal to, suppose, 3 cross validation and scoring accuracy in jobs -1. This is grid done. Now train the model with this grid dot fit x train y train grid grid the model name is grid. Okay, the grid dot predict, simple function, grid dot predict, and from which data I have to make the prediction, x test. Grid dot predict x test. Grid accuracy is equal to grid dot, sorry, we have to use the accuracy score. Okay, the accuracy score y test and y test and grid plate. Okay, after that define also the LazyTune. Suppose the name of the model I am giving lazy, and the class name is smart search. And here also most of the things are same, only the CV will be CV folds. Model parameter metric scoring, this will be metric. Accuracy prune ratio 3, ratio is equal to 0.3, means okay, prune ratio is equal to 0.3, in jobs is equal to -1. Lazy fit, lazy dot fit, we are training the model with these parameters. Okay, with these using the LazyTune, so lazy dot fit x train y train and same things here also, lazy plate, lazy accuracy y test, lazy plate. Okay, and also one thing, we have to use time, so calculate the execution time, import time. Here we can place two things, like where is the training is going on, grid dot fit. Okay, so start grid equal to time dot time. Okay, end grid time lazy start okay. Now suppose we will be training all this and just print the all date data. Print, suppose this is for GridSearchCV. What things we will be printing? First of all, accuracy, grid accuracy, and also n grid minus start grid, the execution time for the GridSearchCV. LazyTune, for the LazyTune, print and lazy, yes. Okay, this is the problem. Wait for the execution. What is the problem? Had error, invalid parameter, max sample split. Wait, same PLES. I think this is not mean sample split. In estimators this is good. In estimators max depth, mean sample split, max depth. Okay, suppose these are all the parameters. Wait for the execution. Start is not defined. Start line number 56. Start grid, अच्छा sorry, start minus grid हो गया. Here you can see that the LazyTune is taking 2.98 second and the GridSearchCV is taking 2.44 second, but the LazyTune accuracy is more 0.746 and GridSearchCV is 0.733. This is because I think I am doing the factory reset of this is I think because of the small dataset. If you try this on the large dataset, on any large dataset, you can find this the LazyTune time will be low, because in the small dataset the GridSearchCV is not doing a large work, because here the dataset is very small. So the LazyTune's 3 phases are over it for the whole dataset, and this is taking the total time. This is taking the more time. This whole process is taking more time. So I think for the large dataset this will give you the better result. Okay, suppose run this all one more time. Yes, here you can see the difference. 0.73336766. This is the GridSearchCV accuracy, and the LazyTune accuracy is more, and also the LazyTune takes less time than GridSearchCV. So you can see that. And also like, if you want to know more, you can check the docs page, and this is in the LazyTune repository, and this is the link, and you also can read the LazyTune readme for better understanding how to use LazyTune. This LazyTune is applicable for all the models in the scikit-learn. Okay, so, and also I have written a blog on this. I can show you that. That's, yes, this is the blog. You can also read this. Here I have explained all of this, and I also have done the benchmarking of the models and other things that are competitor of the LazyTune, like the other hyperparameter optimizers. Yeah, you can see this. Okay, goodbye.